subcooling, if you have an evaporator coil and you have a compressor on the outside and that refrigerant is running from your high side through your condenser coils, and then as it comes out you have your service valve right here, goes all the way over to your TXV, and then goes into your evaporator coils, and then from there your refrigerant's coming up, and then it runs out your suction line, and then comes down your suction line and comes back in here, and here's your service port. So there's your refrigeration cycle. Really good refrigeration cycle there. Alright, so high subcooling is if this liquid line right here, if you're running, and I'm making these numbers up, so if you go to a pressure temperature chart, these numbers are not going to be correct. If you got a 325 pound suction head pressure, 325 psi, I am just going to say that the saturation temperature is, do you have it?
Yeah.
410A or R22?
Both. Which one you want?
410A.
For 325.
Uh-huh.
It is. It actually doesn't have 325. It's 322.
Okay.
Saturation is 101.
All right, so we're at 325 is 101. Okay. Okay. So if I have a 410A system and you got a 325 pound head pressure, your saturation temperature is 101. So as that thing cools down, if I'm reading 90 degrees right here at my liquid line, that gives me an 11 degree subcooling. Okay? Got that? Saturation temperature minus the actual temperature on the line equals your subcooling. Okay? So, if I've got a TXV, so here's my TXV, okay? That TXV is feeding my feeders in here. So that liquid line comes up, boom, feeding all that stuff. If that TXV is restricted, and I go to that system, what am I going to find if I have a restricted TXV? And I'm telling you the system is perfectly charged right now, but my TXV is restricted. What am I going to find? I'm going to find a normal to high head pressure. Normal to high head pressure. Okay? So normal to high head pressure. And I'm going to find a low suction pressure. Okay? And why is it going to be normal to high? Because if you have a restriction, that will raise your head pressure. But it could be normal because it can be pumping the system down a little bit, which makes now, as it pumps the system down, it makes your subcooling go up. So then that is actually cooling that system, therefore it drops the head pressure some. Okay? So it could be normal to high head pressure with a restriction in your TXV. Now you got to think about this. If you have a restriction right here on your dryer, okay, then on this side of the dryer, it's going to be one temperature. On this side of the dryer, it's going to be another temperature. So let's just say I'm reading 90 degrees on this side of my dryer. And if my dryer is restricted on the other side of my dryer, it may be reading 84. That's a 6 degree differential in your dryer. You should not read a 6 degree differential in your dryer. Maybe 1, maybe 2 at the stretching it to 2. Okay? If you're reading 6 degree differential in your dryer is restricted. Okay? So you always want to take your temperature differentials across your dryer. If you go and you take your temperature of your liquid line and it's reading 90 degrees right here, and you go inside to your coil, and as your 3/8 line is going into your coil, go read that temperature on that line there. You may be cooling it down a little bit more because you're picking up heat from outside, right? Or are you dispersing heat outside? If your line is 90 degrees and if it's 85 outside, you're actually getting rid of more heat, right? If it's hotter outside, or if it's going through 130 degrees attic, and it's 95 here or 90 degrees here, and it's going through 130 degree attic, it'll pick up heat, won't it? Okay? So there is going to be a variation. You just got to understand what temperatures you're in. If if you go up to your evaporator coil and you see that line is sweating, the liquid line is sweating, now you know you have a restriction in that liquid line somewhere. So you may have a kink down at the bottom of your copper before it goes through your line, or at the top plate where it bends over, somebody kinked it there. And that'll cause that restriction. And from here, so here's your wall, and your condenser sits out here, and your copper line runs through your wall, up, and then hits your top plate, and then runs over to your evaporator coil over here. Well, right here is where they kinked it. Or right here is where they kinked it at. Well, how are you going to tell that outside that you got a kink at your top plate up there that was put in, 8 years ago? You can't tell. But if you're checking your subcooling and your superheat, you can tell. If you check the temperature of your liquid line up by your coil, you can tell that it's different from the temperature of your liquid line down here. And you're not getting the proper refrigerant through the system, so your superheat's going to be high, right? Your superheat is going to be high because you're not getting the refrigerant through the system, right? We just went over that, right? Restriction in the line gives a high superheat. So if you're reading a high superheat and a low suction pressure, what are you thinking first, Adam? Put refrigerant in the system, right?
Yeah.
Put refrigerant in the system. Just keep putting refrigerant in. Now what is your head pressure doing? Head pressure's going up. What's your subcooling doing? Head pressure's going up, suction pressure's getting larger. So here's the typical thing, Ryan. When you walk up to a normal system, this is the typical Joe Blow air conditioning guy. He's got a restriction and a kink in this line right here that we just talked about, okay? So what he's going to do is he's going to walk up there and he's going to find a normal head pressure. He's going to find a low suction pressure. He's going to find that the suction line is not sweating. So what is he thinking?
Low
refrigerant. So what is he going to do?
Add refrigerant.
Because he's going to grab that suction line, right? And it's not beer can cola.
Right on.
Okay? So if it's not beer can cola, that means add refrigerant, doesn't it? Okay? So he grabs the suction line and he keeps running the system because he's not going to put a high side gauge on the line, is he?
He's not thinking that.
He's not thinking anything. He's just going to put a low side gauge on the line. He can bring his tank out of his truck and start pumping, and then as soon as that suction line starts getting cold, he's good now, isn't he? Well, he just ran the suction pressure up, and it was sitting at 90, and he done ran it up down to 115. Well, 118 is where he wants to be at with a 40-degree coil, but because of that restriction, he can only get it up to 115. He says, that's close enough. I'm cold on my suction line over here. I'm good. I'm good. What's his head pressure doing?
It's going up.
He just jacked up his head pressure. What's the subcooling doing?
Getting larger.
Your subcooling raised up high. Because what's happening is, let's make this a little bit different. We're going to move this 11-degree subcooling over here. And we're going to run that up a copper line right here. We're going to run the condenser out here, and it runs up a wall. We're going to hit the top plate, and then we're going to come in, and then we're going to come on back down to the evaporator coil, okay? So here's the kink in his line right here. So as he's putting refrigerant in that system, it sucks through that compressor, goes through the condenser, through there, boom, hits that kink, starts backing up, backing up, backing up, backing up, backing up into the condenser coils, right? What happens when it backs up, Adam? Remember them coils? The cars backing up at a stoplight there?
Yeah.
What happens? Airflow keeps
It's
going
going
through the coils, right? And as the airflow continues to go through these copper coils, it cools the refrigerant down and gives you a larger subcooling. So what is the condenser doing? It's removing heat from the house, bringing it outside and dispersing it, right? Well, if you keep that refrigerant in the condenser and the air keeps passing over it, it makes it colder, right? So you are cooling the refrigerant down more. You are subcooling the refrigerant down because of that kink. And you keep adding more refrigerant in it, so it's like a traffic jam, and it keeps backing up, backing up, backing up, backing up, and it's just staying there now because it can't get out. If you got some of the cars out of the way, it can get through faster, right? But you keep backing it up. Now you're building pressure up in it. Air keeps going over that condenser coil, and it keeps cooling that refrigerant down. So your subcooling went from 11 to 24. Okay? your head pressure went from 325 to 400. Okay? So if you look at 400 pounds, what is your saturation temperature at 400 pounds?
117.
117. Okay? So if you're doing 117, and if you were reading 90, now you got a 27 degree subcooling. Okay? So as you keep putting refrigerant in, your head pressure goes up, but your liquid line is going to get colder. It's not going to stay the same. It's going to get colder. So those two things will separate now. So your saturation temperature and your liquid line temperature separate, which means your subcooling gets higher. Make sense? Okay. So what causes a high subcooling? Any type of restriction in your high side line if you have a TXV. You charge a system with a TXV by subcooling. You do not charge a system with a piston by subcooling. You only charge a system with a piston by superheat. You take your wet bulb temperature inside, your dry bulb temperature outside, you use a slide chart, and it will tell you what superheat your coil needs to be at, or your suction pressure and everything needs to be at. Your subcooling is determined by the type of condenser that you have. So if you have an old 10, 12 SEER system, you're probably going to be at about a 12 degree subcooling. If you got a 14 SEER condenser, you could be at 10 to 12 degree subcooling. If you got a XC21, if you got a UA17, you're going to be at about a 6 to 8 degree subcooling. If you got an XC25 variable speed system, you'd be about a 6 degree subcooling on that system. Okay? So the higher the efficiency of the system, the lower the subcooling is going to be. Now, the Ruud system, the UA17 model, and if you put in an RCF 6021 SEAM CA coil, that is an electronic expansion valve on that evaporator coil. So you wire this evaporator coil in because it's an electronic TXV, and the electronic TXV wires into Y1 and Y2. That Y1 and Y2 electronically opens that expansion valve up because of the first stage in cooling and the second stage in cooling. Okay? Whereas your typical expansion valve does not have any voltage going to it, this one does. Okay? Uses DC voltage going to it. Okay?
How can you see the electronic TXVs? Or
When you actually install this coil, you can take the face off of the coil, the door off of the coil, and it's mounted inside there. So what you actually want to do is you want to unscrew it from the face of the coil, and it's got enough wiring on it, and you run it down where the tubing is, and you can run it outside the coil, and you mount it outside the coil. So now you can always get to that electronic expansion valve.
Okay.
Okay.
What kind of units are they normally on?
That's a Ruud system, Ruud and Rheem.
Okay.
Yeah, it's a brand new model for that system. Okay. High subcooling. What if you have too much refrigerant in your line? So if you just keep adding refrigerant inside your system, that gives you a high subcooling, doesn't it? What does it do to your superheat with a TXV?
Maintains it.
It maintains constant superheat. Unless what?
I mean, to an extent. Only to an extent.
Yeah, because if you keep jacking your head pressure up, it's like anything. If you've got a hole that is this big, which is your piston size, and you keep jacking up pressure on this side, it's going to force more refrigerant through. Because that TXV is going to try to maintain a constant superheat, and it's going to start shutting itself down. But the more pressure you keep building up on it, it can overtake it a little bit, depending upon how bad it is. But it's going to do its best job at maintaining that constant superheat. So it's either going to be opening the valve to let more refrigerant through, or shutting the valve down to shut more refrigerant off, which is going to back that high side up further. Okay? A lot of times you can see an extremely high head pressure, and you can see a 35 35-degree subcooling on the system with a jacked up head pressure and your suction pressure looks fine. Okay? What if you got a dirty evaporator coil? Is that going to cause a high subcooling?
That's restricting airflow.
It's restricting airflow, which drops your suction pressure, which drops your head pressure, which the dropping of pressures and temperature makes your air coming through your refrigerant coming through the system colder, so it actually does affect your subcooling, make your subcooling cooler, which is higher. Okay, so high subcooling could be affected by low superheats. Okay? Your subcooling is not extremely important on a piston system as far as charging is concerned. It is important, but not as important as like a TXV, because the TXV is maintaining a constant superheat. You charge a system with a TXV by subcooling only. And then you check your superheat to see what your evaporator coil is doing. So if you charge it up to 12-degree subcooling, here's a key factor. Listen to this now. You go put your gauges on the system, and you're charging this system up for the first time. Let's just say it's 80 degrees in the house, so it's not extremely hot. It's 85 outside. And you're going to put refrigerant in the system, so you're charging this system up. The first thing I want you to do is I want you to put your gauges on the system, start putting refrigerant in that system, have your clamps on there, and I want you to run that head pressure up, and I want you to watch your subcooling, and I want you to bring your subcooling up to, let's just say, 10 degrees. And then I want you to stop putting refrigerant in it. Because if you have a 410A system, you might want to do it about 8 degrees first. Okay? If you have a 410A system, you're letting liquid in, right? Because your tank is upside down and you're sucking in liquid. Now you bring it up to about 8 degrees, and then I want you to shut that system off, and I want you to let it run for about 10 minutes. Why? Because that refrigerant inside that system, the liquid that you just put inside that system, has now got to evaporate into a gas. So now you just jacked your head pressure up. So if you let it run another 10 minutes or so, your subcooling is going to keep going up, because that evaporator is going to evaporate that refrigerant. The condenser is going to condense that refrigerant, and it gets through that system, through the systems. Now it starts changing like it's supposed to change, and now you're going to find, I got too much refrigerant in the system now. So if you just keep putting liquid in it and run it up to 12 degrees, you're going to be at 18 degrees by the time you finish. Okay? So run it to about 8, then stop. Let it run 10 minutes, let that system settle, see where your subcoolant sits now, then throttle it in slowly. So as you throttle that refrigerant in that system, now you can slowly bring your subcooling up to where you want. Now when you get the proper subcooling, now you need to look at your head pressure. Subcooling's right. I know I have a TXV. I'm at 10, 12 degrees on my subcooling. Now you have to ask yourself, what is my superheat and what is my suction pressure? Let's see where we are now, because your system is not charged properly if your suction pressure is whacked out. Okay? So let's say you bring your subcooling up to 10 to 12 degrees. You got that 325-pound head pressure that the system's calling for, right? And you're sitting there going, okay, subcooling's at 10, 12 degrees. I'm good. See you later. I'm going home. Well, what if you got a slight restriction inside your TXV, or it's not opening up enough? Well, then your superheat's not going to be proper, right? Well, if your expansion valve's not opening up enough, that's going to cause your subcooling to prematurely get to 10 to 12 degrees, isn't it? Right? So if you don't check your superheat, you don't know what your coil's doing, right? So let's just say now you're running a 28-degree superheat and you're running 12-degree subcooling. What's the problem? You have a restriction. Okay? So that you know, again, a TXV maintains a constant superheat. You know you have a TXV on the system. You know you're supposed to charge this system up to 12-degree subcooling. You do that, you stop, you look at your suction pressure, and instead of reading 118 pounds on your suction pressure, you're reading a 90-pound suction pressure, and you're reading a 28-degree superheat. So your system's not charged properly now, is it? So now you have to go start looking at your high superheat chart. And you go, okay, I'm going to go to my high superheat chart. What causes the high superheat? I got a normal subcooling, right? I've just got high superheat. So we go down the whole chart. This is all the stuff that causes the high superheat. Restriction in the TXV, kink in a line, whatever, okay? High heat load, all this kind of stuff. Well, if you got a low suction pressure and a high superheat, it's not going to be a high heat load, right? Because a high heat load is going to give you a high suction pressure. You remember what I keep telling you? You go back to that chart, and it's got to match everything on your chart, okay? So if I give you a chart that says a restriction in your line has got to have a high head pressure, high subcooling, low suction pressure, high superheat, and you're thinking it's a restriction in your line, if it don't meet all four, it's not a restriction. If it meets 3 out of 4, but the last one is low instead of high, it's not it. Okay? Well, it might be it. It's 3 out of 4. No, it's not. It's not. Okay? It's not there. Okay? So any type of restriction inside that line will cause a high subcooling. What if you take a hose and you go hose the condenser down? Will that give you a high subcooling?
Water, just add water.
Okay. Just spraying it down with water will give you a high
Is it low?
subcooling.
Water.
It'll give you a high subcooling because you are taking the heat out of the condenser. You are subcooling the refrigerant down. Okay? What if you have a dirty condenser then? High subcooling or low subcooling? Right. Because you're not taking the heat out of the condenser, right? What if your fan motor is not adjusted properly and you're not removing the amount of airflow through that system? High subcooling or low subcooling?
Low, same thing.
Okay. What if you have too much airflow running through that system because somebody put the 1550 RPM fan motor on it when it's supposed to be 825? Now you get too much airflow through it. High subcooling or low subcooling? High subcooling. Okay. What if a dog continues to urinate on the condenser coils and corrodes the condenser coils and they're clogged up a little bit at the bottom, but they're falling apart in some seams and you only have the copper lines running because the aluminum's all messed up? High subcooling or low subcooling?
It's going to be low. Or, I mean, yeah, it's low because you're not getting everything across.
And I get everything across, right? It's not transferring the heat properly.
Right.
You got to remember, the aluminum on those condenser coils is actually transferring heat. Okay? So I want you to think about this when you're going out and you're doing the maintenance contracts. I had a technician last year that he would continually bring me in invoices, and I'm looking at them and I'm going, you're not cleaning the condenser coils. Tell me why you're not cleaning the condenser coils. He says they're not dirty. So he's bringing them left and right, left and right, left and right. Finally, I take his invoices and I start looking up history on this customer. Look, this customer has not had service with us in 4 years. You can't tell me that condenser coil is not dirty. Look, we haven't serviced the system since February of last year. Look, we haven't serviced it in 2 years. I'm finding every single one of them that he's going to. He just looks at the condenser coil and looks not dirty. So I don't have to clean it. That is so wrong. If you haven't been to that house in a year, it's dirty. End of story. You need to clean the condenser coil. Every condenser you go to, if you don't tell that customer that we need to clean your condenser properly before I can get your head pressure, suction pressure, superheat, and subcooling, you are not doing the proper job for that customer. Okay? Yes, we make money out of it, but yes, that's what pulls the heat out of the customer's house. Let me give you a sales pitch on that, okay? Ryan, I went and checked out your system just a few minutes ago, and one of the things I was checking out, man, your condenser is filthy dirty. Let me explain to you what the condenser does. The condenser actually takes the heat from inside the house, brings it outside, and the compressor pumps that gas into a hot gas. As that hot gas runs through those condenser coils, the airflow going over the coil actually disperses that heat outside. Well, if your condenser coils are dirty, what it does is it transfers that heat right back around inside your house. So you're just trying to cool the same air over and over and over and over and over. So you're running your energy bill up. It's $98 for me to ask to wash that condenser, and I'm going to take a lot of that dirt and debris on that condenser, take it out. I'm going to take the oxidation off of the metal. I'm going to allow for better heat transfer on that condenser. Would you like me to go ahead and clean the condenser for you right now? Because I really need to do that in order to check your pressures properly.
Why wasn't I told this last time?
The reason you weren't told it last time is the guy might not have thought it was dirty. So one of my jobs when I come here today is to make sure that your system works at 100% efficiency. So I'm checking your system out right now, and your head pressure's running a little bit high. I checked your history, and I've seen that it was not done last time, so that's why it really needs to be done today. I can do it for you right now if you'd like.
Definitely.
You got it, man. I'll take care of it for you.
Thank you.
Okay. You've got to make sure that when you go to every job, these condensers are cleaned properly. Okay? So you got to look to make sure that the condenser coils don't have a double coil. The old Lennox systems, when you look at the top of the coil and the inside, it's a double coil. And nobody ever cleans it. I'm telling you, nobody ever cleans that coil. It's an old HS29 condenser. Got a flat top to it. You take the front panel off of it, compressor sitting in the side, electrical up here. I'm sure you have seen these Lennox condensers. That condenser, you take that top piece off and the fan motor's still sitting in there. You look inside there, the condenser coil comes down and then goes this way and then this way. Double condenser coil up at the top. You start hosing that condenser coil off and then you spray it with a chemical, it is going to be just black coming out of it every single time because nobody ever cleans both coils. So that's very important when you go to any job. You need to look and know the types of systems that you're going to on a regular basis so that you can determine what kind of system it is. I'm going to give you another example. Train unit, American Standard System. I hate them. And the only reason I hate them, this is the only reason I hate them, they're a pain in the behind to clean. Okay? They got the spiked porcupine fins on them, right? So if I'm going to clean that condenser, and here's what I tell a customer, that the reason I don't sell Train and American Standard is because I don't like their condensers. And if you got 3 dogs laying around that condenser, that's like 3 dogs laying around a spiked porcupine, and it sucks all the dog hair up into that porcupine. Now I've got to clean the porcupine fins out, okay, with 3 dogs, stuffed up into that porcupine. So you can get so much dog hair, and I see it all the time. So if you go up to an American Standard system or a Train system or OGE system, it's got those spiked fins on them. You better charge a little bit extra to clean that condenser because a lot of times you got to clean it 3 times to get it clean. Okay? You got to take the top off of it, which is 15 screws all the way around it. You got to take the 2 sides off of it. You got to kind of bend the other 2 sides out. You got to hose down the big dirt on it. Then you got to shoot from the inside out, just with the hose, just to get the big stuff off of it. So you're cleaning it once like that, just with the hose to get the big stuff off of it. Then you're going to spray it down with the chemical and bubble everything out of it, foam all the dirt out of it. Then you got to hit it down again. And a lot of times, once you do that, you actually got to hit it one more time because it's just filthy, filthy, filthy dirty. Especially if they're sitting in the dirt and they got dogs around it. Okay? So that condenser is going to take you longer to clean than a Lennox condenser or a Rude condenser that we normally sell. So we have to charge appropriately for that particular condenser. And it is what it is. Sometimes you got to almost jump inside the system in order to clean it. So how is cleaning a condenser? What do you do when you clean a condenser? You literally take the fan motor off of it. You clean all the leaves out of the inside of it and take them out. Then you hose the inside of it out and get the leaves out of it. Because if the customer comes home and sees that you were supposed to clean the condenser, he goes and looks in the inside, it's full of leaves on the inside. Did you clean it? No. Well, you did clean the condenser coils, and the leaves literally affect nothing, but you didn't clean it. It's still dirty.
Perception.
That's
Right.
the first thing they're going to see.
Right. Okay, and that's happened many a times. Customers calling up because of that. Your guy was supposed to clean it. Or how about this? You take the cover off of the Rude system, you got the compressor sitting in the electrical compartment right here, right? Well, that part of the condenser coil gets filthy, filthy dirty right there, right? You got to clean that really good. What about at the bottom of it? Well, you got to clean that too, and you got to hose all that stuff out. Let me tell you what a clean condenser looks like. When I'm walking up to the condenser and I look at it from this far away, it's clean. The slab is clean around it. There's no dirt and leaves around it. So if you get to that system and you've got an oak tree sitting over the top of it, and it's dumped all the leaves inside the condenser, and it's piled up around it, and it's got concrete around it, and these people don't maintain their house properly, when you leave that system, you see the concrete because you've hosed everything around it, and now the water can drain out of the system. You've pulled all the leaves out of the inside of it, you hosed the inside of it, and it's clean. That is a clean condenser. So now when I get home as a customer, I walk up to it, and I can see from here that you've cleaned the condenser, because I know the leaves were piled up 6 inches around the whole thing. I know it was. And now you cleaned it all out. I don't care. Clean it. Make that customer understand that you did the work you said you were going to do. We don't want to lie, cheat, or steal. Okay? I have no problem charging a customer for what we do, but I don't want to charge them for something we don't do. All right? Very important. High subcooling. What else can cause a high subcooling? We said any kind of low airflow through the system can cause a high subcooling because it's going to lower your head pressure and lower your suction pressure, which can cause a colder evaporator coil, which can give you a colder condenser coil. What else is going to give you a high subcooling? Any questions? Any suggestions in there, guys? What if you got too big of a high side line?
Too big of a high side?
Mm-hmm.
It's going to be low too. It's going to be pushing more down and up.
It can cause you a low head pressure, okay? And it can affect your subcooling, but when you're charging the system, mainly means what kind of TXV do you have? Or what kind of metering device do you have? Do you have a TXV or a piston? You can have very weird subcoolings with a piston because you're not worried about what your subcooling is with a piston. You are going to worry about your subcooling with a piston if your condenser's dirty. And you should be cleaning your condenser because it's easy to see, and you should clean every condenser that you go to, right? Okay? So make sure that when you go to a job, you are cleaning these condensers. I'm going to go through one quick one for you here. You go to a job and you have a normal looking head pressure, a normal looking suction pressure, fairly normal superheat, and a fairly normal subcooling, or a really high subcooling basically. I'm sorry, a low subcooling. And you look at the condenser and it is completely filthy, filthy, filthy dirty. So you go ahead and you tell the customer, man, I've got to clean your condenser. It is completely filthy dirty. He goes out there and he sees it. He watches you clean everything out. You're pulling leaves out of it. You're hosing it out, and dirt's just, grime's just coming out of it. Man, he's well worth cleaning this condenser, right? After you put it all back together, you start the system up, and about 10 minutes later, your suction line's freezing back. Why is your suction line freezing back?
Low refrigerant.
Could be low on refrigerant, but it's probably not going to freeze back being low on refrigerant at that point in time that fast. Okay? Adam?
The evaporator's dirty too.
The evaporator coil is dirty, therefore you dropped your head pressure down, which now you dropped your suction pressure down. Now your evaporator coil is going to get colder and colder and colder because the only thing that was caught was not allowing it to freeze before was because your high side was so hot because it was dirty and that heat was going through your liquid line. So literally when you grab that liquid line, it was hot to the touch. And when it's shooting back inside, your head pressure was really high, your suction pressure was really high, your evaporator coil temperature was high, so it wasn't allowing it to freeze. Now you clean the condenser coils, you dropped your head pressure, you dropped your suction pressure, and now your coil starts to freeze because your pressures and your temperatures drop down. Now he just got finished cleaning the condenser, now you got to clean the evaporator coil. Then you clean the evaporator coil, and 2 days later his fan motor goes out on him because the bearings are bad in his fan motor because the condenser was so dirty it was causing the bearings to go bad, so you replaced the fan motor, and then 2 more days later his compressor fails on him because the system's been sucking in liquid all this time. Okay? So he's mad at you now. Okay? So what you should have done was check the entire system first, right? And tell him you got a dirty evaporator coil, you got a dirty condenser coil. Very possible when I clean this evaporator coil, I don't know how much damage is done to your compressor, so I don't know how long it's going to last. I don't know how long your condenser fan motor is going to last, simply because you've been running this system for the last 5 or 6 years or so, and those bearings have got really hot, so if I clean this condenser, it's possible your fan motor will go out on you. So I can put probably $900 to $1,000 into this system, or I can take a look at replacing the system and put that money into a new system. My recommendation to you is to put that money into a new system. I really think it'd be worth it instead of putting good money into bad in this one. Make sense?
And I give you a warranty with the new system.
We give you all new warranties, 5 years on all the parts, 1 year on labor, 20 on the heat chamber, 10 on the compressor. I think it's well worth it that you do that instead of putting this $1,000 into the system. But if that's not feasible for you, I can clean your coil and clean your compressor and the whole 9 yards of it. Which one would you like me to do? Would you like me to get your price on the new system? We have financing available and everything. Okay, well, let's go ahead and do that. I can write that up for you right now. Okay. All right. Man, I'm trying to think of some more things with high subcooling. Really, restrictions in your lines are going to cause you high subcooling. Restrictions in your lines or too much refrigerant in your lines are going to give you high subcooling. That's the main things. Low airflow can give you high subcooling. Any kind of low airflow. We went through the gambit on that with low superheat, right?
Yeah.
Okay. So all that stuff. When you get to a system, check your head pressure, check your suction pressure, check your superheat, check your subcooling. Now you know where the system stands. All right. Let's go to low subcooling, and we'll go from there.